is Unit 3, Day 3. Is that correct? Unit 3, Day 3. All right, so today we're going to do some segment proofs. So before we do some proofs using segments, so Friday we did some proofs with algebra, right? So we learned our algebraic properties of equality, which is basically what we do to both sides of the equation, right? To solve it to get to the next step. So today we're going to do some segment proofs since we learned about segments in Unit 1, and those are vaguely familiar to some of us. We can also use our properties of equality. This is just a review of what those were. Okay, we already talked about those. So today we're going to talk about properties of congruence. So we talked about properties of equality on Friday. Today we're going to talk about some properties of congruence. Now we know that congruence has the congruent symbol, which is the little squiggle line and then an equals, right? And equal properties of equality have an equal sign. It's an equation. All right, the difference in congruence and equations are, congruence is when we're talking about the actual object, like the segments themselves. Okay, equal signs are for when we use their measures. So we say the objects are congruent, their measures are equal. The objects themselves are congruent, the measures are equal. Okay, so first we have a reflexive property of congruence. For any segment AB, what did reflexive property do for us the other day? What did reflexive property do? What did it say, basically? Something equals itself, right? So the reflexive property of congruence is going to say that segment AB is congruent to itself, segment AB. So the reflexive property of congruence says anything is congruent to itself. Okay. Now, what did symmetric property do for us the other day? Swap the order. So if segment AB is congruent to segment CD, then we can swap the order and say segment CD is congruent to segment AB. Okay. Swap the order for symmetric. And then we have transitive property, and transitive property works like it did for equality at the same time. So what did transitive property do for us?
If something equals something, that's something equals something backwards, and the other something equals the other something.
Yeah. I like to say if two things equal the same thing, then they equal each other. Right? So for congruence, if two things are congruent to the same object, then they're congruent to each other. So with our segments we got going on here, if segment AB is congruent to segment CD, and segment CD is congruent to another segment, EF, what can I say? If they're both congruent to CD, then what? AB is going to be congruent to AF, right? Or EF, sorry. AB is congruent to EF. So if two things are congruent to the same thing, like here they're both congruent to segment CD, then those segments are congruent to each other. Okay. So those are the three properties of congruence. Reflexive, symmetric, and transitive work just like they did for equality. All right. Here's a few new ones. These are properties we can use definitions for. All right. Now remember I just said to you a while ago that we say objects are congruent and their measures are equal, right? So the definition of congruence says if segment AB is congruent to segment CD, then that means they have equal measures. And remember when we did the measure of a segment, we called it the length of that segment, right? And remember our symbol for that was just the capital letters with no symbol with it, right? So you say the object segment AB is congruent to the object segment CD, and their measures are equal. So remember, measure of a segment is just the capital letters with no bar or anything. So that means the length of the segment, which is the measure of the segment. So the objects are congruent, means their measures are equal.
What's the separation between congruent and equal?
Because it's different. We're talking about the objects here. These are their measures. So this tells me if the length of segment AB is 5 inches, then I know the length of segment CD is 5 inches. Okay? The objects themselves are congruent, which means they have the same length, but we say the measures are equal and the objects are congruent. It's just one of those funny, finicky, pet peevey geometry things that we have to say. Okay? The converse is also true. If the lengths are equal, then the objects are congruent. If the lengths are equal, then the objects are congruent. So this is just the converse, and we learned last week what a converse was. We can swap the order. So it goes both ways. We can go from lengths to objects, or we can go objects to lengths. The objects are congruent, the measures are equal. Okay, so that's the definition of congruence. We also talked about in Unit 1 the definition of a midpoint. Somebody tell me something you remember about a midpoint. It's bisecting a segment, right? What's another way to think about a midpoint? It's the point in the dead center of a segment, right? It's equidistant on both sides, right? So the midpoint of a segment divides the segment into two equal or congruent parts. If M is the midpoint of AB, then the length of AM equals the length of MB. Or if you want to say the objects themselves are congruent, you would say segment AM is congruent to segment MB. Okay, either one of those. Okay, those both follow the definition of a midpoint. They told me M is the midpoint of that segment, then the length from A to M is the same thing as the length from M to B. And those two segments are congruent segments. All right, the bottom of that page is segment addition postulate. What was the quick way we remembered segment addition postulate in Unit 1? What did I tell you to remember? So, little plus little equals big, right? So AB is one little segment. It's not really a little one because it's bigger than BC, but it's not the whole thing, right? So the two little ones make up the whole thing. So the length of AB plus the length of what? BC equals the length of what? AC. Okay, so you're talking about measures here, so we're going to use an equal sign. Good job. Now flip to the back. Y'all, this is what we need to know. This is for sure what we need to be able to know how to do. Okay, it has you the bank at the bottom where it lists all the properties, right? Okay, so let's see if we can just fill this in together. Number 1, if the length of PQ equals the length of PQ, then segment PQ is congruent to segment PQ. Which property says that, or which definition, or whatever? If the lengths are equal, then the segments are congruent. What says that? Very good. So this is definition of congruence. If their lengths are equal, then the segments are congruent. And that goes both ways. If the segments are congruent, then the lengths are equal. All right. So number 2 says, if K is between points J and point L, then the length of JK plus the length of KL equals the length of JL. What says that? Is this a midpoint? No, because it didn't say anything about them being congruent lengths or midpoint, right? So this is segment addition postulate. Very good. Segment addition postulate. And I'm okay if you abbreviate as long as I know what you're talking about. Postulate. And I'm trying to spell postulate and I can't. There we go. Number 3. Segment EF is congruent to segment EF. What says that? Reflexive property. Very good. Anything congruent to itself is reflexive. Okay, look at number 4. Might be confusing. It tells me RS equals TU. So the length of segment RS equals the length of segment TU. Then the length of RS plus the length of XY equals the length of TU plus the length of XY. What did it do? It added XY on both sides, right? Started with just RS and TU, and then it added XY on both sides. So what property says you can add the same thing on both sides? Addition property. So you see how we're blending all of these together? So all the properties we know is getting blended together. So anything that's on the bottom of that question bank we can use here. All right, number 5 says if the length of AB equals the length of DE, then the length of DE equals the length of AB. What says that? Symmetric. Very good. If we reverse the order, then that is always symmetric. Is that okay? I should put property, but if you don't, it's okay. Number 6, if Y is the midpoint of segment XZ, then the length of XY equals the length of YZ. What says that? Very good. Definition of a midpoint. Is that okay with everybody? All right, number 7. If segment FG is congruent to segment HI and segment HI is congruent to segment JK, then segment FG is congruent to JK. What says that? Transitive. They're both congruent to HI, so they must be congruent to each other. So that's the transitive property. We doing okay with these? Because I'm serious, this is what's on our quiz Wednesday, stuff like this. Number 8, if the length of AB plus the length of CD equals the length of EF plus the length of CD, then AB equals EF. Well, how did I get from this to this? Yeah, they got rid of CD on both sides, right? What property says I can get rid of them on both sides? Yeah, they add them on both sides, so I can get rid of them using subtraction. So that's the subtraction property of equality. Very good. And make sure don't abbreviate subtraction, because it could be substitution. All right, number 9. Am I looking at number 9 with me? It says, if the length of PQ plus the length of RS equals the length of TB, and RS equals, does that say WX? Okay, so these two equal each other, and RS is right there, then PQ plus WX equals TB. What did they do there? Yeah, if two things are equal, then you replace one with the other. That is the substitution property. So again, don't abbreviate that, please. And maybe I spelled it correctly. Number 10, if the length of LP equals the length of PN, and LP and N are collinear, what does that mean? They're on the same line. Then P is the midpoint of LN. What says that? P. P is the midpoint of LN, so LP equals PN. Yes, definition of a midpoint. And like I said, that was one where the converse is also true. And yes, we use that twice, and that is okay. Number 11. If segment UV is congruent to segment UV, then the length of UV equals the length of UV. What says that? Yes, if the objects are congruent, then their lengths are equal. And one more of those. If the length of CD plus the length of DE equals the length of CE, then CD equals CE minus DE. Whoa. Yes. What'd they do on both sides? They subtracted this DE, didn't they? Right, CD and CE are there, and they subtracted it and moved over there. Subtraction. Very good. Subtraction. Property. So any questions about these filling in these properties? We good? All right, get out your segment proofs handout. And I've got to make sure mine looks like y'all's because I kind of skipped around. And I know y'all's numbers are not really, I mean, they're in order, but they're skipped, right? Right? Okay. So we're just going to try. All right, number 2, which is the first one, it looks like this, right? Right? Yeah, okay. So this is our first geometric proof. Congratulations. You made it to real geometry now. Okay? This is real geometry. Okay, now luckily for us, what did they do? They filled in all the statements, didn't they? Yeah. So all we have to do is fill in the reasons. Now what can be a reason? A definition? A property? Right? Or a postulate and theorem. And we don't know any postulate or theorems yet. Well, segment addition postulate, right? That's the only postulate we know. Well, we know angle addition, but we're not doing angles today. We'll do those tomorrow. Okay, so they have listed all the statements, right? We have to just fill in these 4 reasons. So using our properties or our postulate we know or our definitions that we know. Okay, so look at here. Notice it says the given. Is that what step 1 is? Yeah. So what's our first reason? Given. Your first reason is always, always, always going to be given. And your first statement is going to tell you what the given is. So I'm just going to read that. Segment KL is congruent to segment LN. I'm going to mark that. KL. Stop it. Remember we mark congruent segments with just a straight little bar? Not LN. LN. So these two are congruent. And LM is also congruent to LN. So I'm going to put 1 tick mark on all because they're all congruent to each other. All right. So they tell me that those different ones are congruent to each other. Then they skip down here. What's different from step 1 and step 2?
They're not the.
There's no longer measures.
Right. So it went from segments are congruent to the measures are equal. So which property, definition, postulate, whatever tells us if the objects are congruent, then they have equal measures. Definition of congruence. So step 2 reason is definition of congruence. And if you want to put a congruent symbol for that, I'm okay with that. Because we learned that was a symbol already, right? All right, so now we're going from step 2 to step 3. KL equals LN and LM equals LN. So now I'm saying KL equals LM. What do you think? They're both equal to LN, aren't they?
Yes, so
So
transitive.
So that means they must be equal to each other. So that is transitive. Very good. Transitive. Okay. So, y'all see how I did that? They were both equal to LN. So step 3 says that KL and LM are congruent to each other or equal to each other. Y'all see that? Why it's transitive? All right, last thing I need to do. The last thing it says is it's proven that L is the midpoint of KM. Well, don't I know that KL is congruent to LM? They just told me that here, right? So that means L must be the midpoint that's between K and M, right? So what tells me that that's a midpoint? Definition of a midpoint. Very good. Congratulations, you just did your first geometric proof. Don't you feel like a smarty pants?
No, no.
Okay, what are we doing? We're practicing, right? We're practicing. We're not going to have to do any of them all on our own until next unit. So we're just practicing. Let's look at number 5, which looks like this, right? And we'll unzoom it a little bit. Is that number 5?
Yes.
Okay. All right. So first statement is what? It's a given. Now I'm going to go and mark on my paper what they said was congruent. Okay? It told me XY, which is this little segment right here, is congruent to UV, which is this segment down here. Right? Mark it, mark it, mark it. If you don't mark, you're not trying. And it tells me YZ, which is the shorter segment on the first segment, is congruent to TU. So I'm putting 2 tick marks to show which ones are congruent to what, right? The ones with 1 tick mark are congruent to each other. The ones with 2 tick marks are congruent to each other. So that is given to me, and I marked it. Okay, if you know it, you can mark it. If you don't know it, don't mark it. But they told us that, so I can mark it. All right, so from step 1 to step 2, what happened? They went from congruent to equal, right? What says you can do that? Definition of congruence. Very good. Definition of congruence. Okay, then they broke it down. They said XY, which is this one, plus YZ, which is the little one, equals the whole thing, XZ. And over here they said I'm skipping right here. TU plus UV equals TV. Which property, postulate, whatever, says that little plus little equals big? Yeah, and they just did them both at the same time. And that's okay. So that one is segment addition postulate. Segment addition postulate. Y'all see that? You gotta actually look at the letters and know what segment it's talking about. Okay, so then they went from step 3 to step 4. What's different between step 3 to step 4? Well, this looks different, right? And this looks different, right? Right? Was there something above that that told me that those two are equal and I can swap it? So this one went from XY to UV, but didn't step 2 tell me those two were equal? Y'all see that? Y'all see that? So you can use anything you have said as a statement above it. Okay? And then right here, TU changed to YZ. Now, didn't I already learn that those are equal? Now, which property or whatever says if I know 2 things are equal, I can replace them? Substitution. Very good. So if you've already stated it, then you can use it in a proof. Anything you have previously stated, you could use. All right, now how did they get from step 4 to step 5? XZ equals TV. Well, isn't that what they were both equal to? Well, isn't YZ and plus UV the same thing? Right? So aren't these two the same thing? So if this equals that and this equals that, then they equal each other. Is what property? Transitive property. Very good. So even though they're different order, that is still the same thing, isn't it? Because addition means you can swap the order. So that's the transitive property. And then, what did they do from step 5 to step 6? Yeah, they went from equal measures to congruent objects, right? And that is definition of congruence. That's it. How are we going to get good at this? It just takes practice. I know y'all feel like y'all are swimming out in the deep blue sea looking for a life raft, okay? It gets better with practice, trust me. Like me trying to play the key of B. All right, gets better with practice. All right, go to number 7. It looks like a 1, but it's really a 7. Does it look like that? Now, what's different about this one?
You gotta do both sides.
I don't know what this. Yeah, they give us some statements and some reasons, don't they? I don't know what this is on my number 4. Ignore whatever this is. Oh, it went away. Okay. They gave us some statements and some reasons. So we're going to kind of go back and forth. Sometimes we're going to have to tell some statements. Okay, and to me, those are a little harder. But it tells us what reason to use if it doesn't give us a statement, so that helps a little. So they tell me, okay, this is what I don't like when they do this. I like to put all of my given on step 1. They didn't do that, did they? No. So first they tell me E is the midpoint of AC. That one's given. You see that? And then they leave off this part of the given, didn't they? Right? But if you look down, they give you a given right here. Well, the only thing that's given that's not mentioned already is the DE equals EC. Y'all see that? So go ahead and fill that out. So if they split up the given, go ahead and find where they do that out and copy, okay? Sometimes they do that. I don't like it when they do that. I like to give all my givens at once, but some people don't. Okay? So if they split your given, go look for the other given and fill it in. All right, so I'm going to mark some things I know, okay? E is the midpoint of AC. Well, here's segment AC. E is the midpoint. So with that being the midpoint, I know that these two segments are congruent. Y'all agree? Okay? And it says the next thing is definition of a midpoint. So that's going to be my next statement. Is which two lengths are equal?
AE and
AE equals EC. Okay. AE equals EC. And that's definition of a midpoint, right? Okay. So then I did my next given, which was DE equals EC. They told me that to start with. So I'm going to mark that one congruent. DE equals EC. So those three are all going to be congruent together, aren't they? Right? And that's what it says down here. I went from AE equals EC and DE equals EC. So this one says AE equals DE. Now what property says I can say that? They're both equal to EC, so they're equal to each other. So what says that? Transitive. Y'all see that? So sometimes transitive will be on the same line and sometimes will be split in two different statements. Y'all see that? They can be split. So the number 4 reason is it's the transitive property. We don't like much, friends. All right. So then it says I need to use the definition of congruence from here to here, right? So am I starting with measures or segments? Measures. So I need to go from measures being equal to segments are congruent, right? So I'm going to say AE is congruent to segment DE. And that's the definition of congruence. I went from equal measures to congruence. Dun-dun-dun. And then, okay, what's the difference in statement 5 and statement 6? They reverse the order. So which property says I can reverse order? Symmetric property. So these are not so bad because they at least give us part of it, right? When proofs get hard is when you have to do all the statements and all the reasons by yourself. Yeah, don't worry. We'll get there. All right, flip to the back. We're going to do number 8 and number 9. Okay? Number 8 and number 9. RS equals 1/2 RT. We're proving that S is the midpoint of RT. Okay? So, my first reason is what?
It's the given.
It's the given. They tell me RS equals 1/2 RT, and that's all they give me for the given. So that's what I'm going on. Okay? So I don't have to go back and fill in any more givens because that's all they gave me in the given. Y'all see that? All right, then the next one goes from this equation, RS equals 1/2 RT, to 2 times RS equals RT. How did they go from here to here mathematically? Multiply both sides by what? 2. Because if I multiply by 2 over here, they'll cancel out and have 2 times RS over there. So that is the multiplication property of equality, right? Okay. Next, I have to fill in statement number 3. And I don't know what that is, but my clue is here to use the segment addition postulate. What does basically segment addition postulate say? Little plus little equals big, and they have this picture up here for me, right? So how am I going to do segment addition postulate from this picture? And these are an equal, so their lengths equal. So I'm not going to use congruent or segments. I'm going to use the lengths. So how can I write that in segment addition postulate? RS plus ST equals RT. Very good. And that's the segment addition postulate. Little plus little equals big. Is everybody okay with that? Okay. So from one step to the next, I got 2RS equals RS plus ST. What did they do here? Use all your statements. How did they get from 1, 2, and 3 to step 4? Well, where do you see RS earlier? 2RS. Where do you see this one at? On step 2, right? And it says it equals RT. And where do we see RS plus ST? On step 3, right? Also equaling RT. So they both equaled RT, so that means they set them equal to each other. So they used what? Transitive property. Are you starting to see that transitive is used a lot? It is. It is. Transitive property. All right, this one's a little bit, could be a little complicated. They go from step 4 to step 5. Let's just think about equations wise, right? Isn't there an RS right here and an RS right here? Yeah. So they kind of combine like terms, so to speak, right? You got the RS's together, so what did they do on both sides? Subtract the RS, and don't that leave you with one RS and then no RS's over here? Y'all see that one? So that one's kind of hard to see. So that one is subtraction. All right. So now they will finally say that RS is congruent to ST. Right? So and that's what they did with subtraction. And it said I need a statement based on the definition of a midpoint. And also, in our last statement, it's supposed to be what you're trying to prove. Yes. So that did prove that S is the midpoint then of segment RT. So you copy what it says right here. S is the midpoint of segment RT. So your very last statement should always be what it says to prove. Okay? So again, you should never turn in a blank proof. You always can be able to fill in this, this, and this, no matter what. Right? The first statement, first reason, or first statement, first reason, and the last statement. Just from this. Got it? Okay. Let's do one more together, then I'm going to let y'all practice them. Let's do number 9. All right, number 9 is similar. There's a bunch of different segments though broken up in this picture. Y'all see that? How many givens are there? There's two different givens. How many givens are listed in statement one? Just one. So the first one is M is the midpoint of LN. That is given. All right. Where did they list the second given at?
3.
3. So my third statement is going to be yes. So write that down for your third one. So that one's also given. So I'm going to go back and mark LM equals MN, LM equals MN, and N is the midpoint of MO. So there's MO, this segment. So that means that these two segments, MN, is equal to NO. And what says that if I have a midpoint, then two segments are congruent, or two segments are equal? Yeah, that's also definition of a midpoint. Very good. So far that one's not too bad. All right, so look at step 2 and step 4. Those might be the most ones we can use. And it says also to use the transitive. So there's a clue. LM equals MN and MN equals NO. So what do you think I can say right here? Very good. LM is equal to NO. And that is transitive property, isn't it? Two things equal MN, so they equal each other. All right, then it says to use the definition of congruence, and plus the last given should, or the last statement should match what you're trying to prove. So what's going to go in the very last blank? Yeah, the segment is congruent to the other segment. All right, this is honors. I want to do it. But you know what I didn't do? Look what I don't have on mine. I don't have the table, so I got to be old-fashioned and do my statements and reasons. But y'all have yours, don't you? Yeah. Did it for y'all. Didn't even do it for myself. That's love right there. That's love right there. But they didn't give us any statements or any reasons, did they? No, we got to do it all ourselves. Are y'all scared? I'm not. I might be scared. I'm not. Y'all should be scared. All right. Bless you. So number 1. What did I write down first? Given. AB is congruent to CD. And the first reason is always. You should never turn in a blank proof. Not even on a bonus. I mean, come on. Y'all can do that, right? Okay, I'm going to mark it. AB is congruent to CD. All right? All right. Okay, now this one's a little crazy. Do y'all see how like BC is kind of hanging out there in the middle? Y'all see that? I got two segments congruent to each other, and then the little segment BC is hanging out there in the middle, right? So I need to use that in some form. So I'm going to use this segment and then this segment and do segment addition postulate with those. Y'all see that? Because they're sharing that BC. So my step 2, I'm going to say AB plus BC equals AC. And that's segment addition postulate. I cannot spell postulate today. And then step 3, I'm going to do the same. Amanda Isbell. Go away. Go away. Step 3, I'm going to do the same thing with the bottom segment. BC plus CD equals that segment, which is BD. Right? And that's also segment addition postulate. Computer's getting hot. I cannot spell postulate to save my life. I should just write post period. Okay, now okay. You know how I said that I can replace two things that are congruent, right? So right here where this CD is, can I replace it with AB? Right? So that's what I'm gonna do. I'm gonna say BC plus AB equals BD. Right? So where they had CD right there, I placed it with AB because of that. And so I use substitution. I'm gonna run out of room. Substitution. My handwriting is beautiful today. Anybody else feeling me? All right. So now, looky here. Do y'all see this? I have two things equaling BD, don't I? Right? So I can equal them to each other. So I can say BC plus CD. Oh, yeah. Do I have this or do I not have this? I'm trying to prove AC. Oh, yeah, I got this. Equals BC plus AB. Oh, I've got this. I think. Do I have this? Okay. Okay. So this isn't that. Isn't this that? What was that reason? That was transitive, wasn't it? And you see how this equals this. Whoops. Y'all see that? Uh-huh. So if that equals AC, then now I can say AC equals BD. And that was substitution. Oh, Lord. This is a crazy proof. Aren't y'all glad I'm doing it, not y'all? And then lastly, what am I trying to prove? They're congruent to each other. Did y'all run out of blanks yet? Okay. Y'all got one more? Good. So now finally I can say AC is congruent to BD. Now what went from step 6 to step 7? Yeah, I went from equal to objects are congruent. Whew. There we go. That was a fun one. Way to go, honors class. That's the end of notes for today. Miss Isabel's tired.